So here is an example of time variant system. Y of n is equals to x of n square. Here the shift of n naught in x of n doesn't give the shift of n naught in y of n. You can see here it is x of n square minus 2 and n naught plus n naught square. So we can say this is a time variant system. Now let's discuss system representation using its impulse response. Here is a input signal delta of n. It passed through the system and gives us h of n, where h of n is called impulse response. Okay, when x of n, an input signal passed through h of n, an impulse response system, it gives off an output y of n. We can represent this output as y of n is equals to summation of multiple of h of n minus k into x of k, that is convolution of x of n and h of n. We can represent its shifted version, that is delta of n minus 1 gives us h of n minus 1. Delta of n plus 1 gives us h of n plus 1. Meanwhile, the shift of n naught gives us shift of n naught in h. So we can say that applying this system to the input x, we get x of k, delta of n minus k, and their summation. So here it becomes h of n minus k, that is impulse response. So we can write this as this formula. Let's see why we found an impulse response system and how it is beneficial for our use. Let's suppose a system is this, and y of n is equals to x of n minus 2x and minus 1 plus 3x and minus 2. So here is the system. Signal x of n will do calculations here and put every single value in here, that is x of n. For negative values, x of n will be, like suppose if we take minus 2, x of n will be 0, because there is no value of x at minus 2. Meanwhile, for minus 1 it has no value, but putting minus 2 in here we get minus 3. So we get 0 value over here, minus 2 minus 4, it gets 0 value. We start having value from y of 0, because x of 0 over here is 1. So minus values are 0. So for y of 1, we'll calculate like putting 1 here, we get x of 1 is equals to 1. 1 minus 1 0, so minus 2 x of 0. X of 0 is 1, and when it is multiplied with minus 2, we get minus 2. Minus 2 plus 1 is minus 1. In here we get no value because it will go in negative side. So we have to put all the values over here, and we have to find the response of the signal, the output of the signal. We use impulse response instead to reduce our work. We know that impulse signal gives value at 0 only, so it gives 1 and 0. So we convert the system in impulse response as instead of y of n, we write h of n is equals to delta of n minus 2 delta of n minus 1 plus 3 delta of n minus 2. So we can use this impulse response in this way, that delta of n is equals to 1. We know there is no value except delta of n, so there are 0. So h of n is equals to 1. H of 0 is equals to 1. Delta of 0 is equals to 1. So when we put minus 1, so we have no value because there is no delta of n. So when we put minus 1, there is 0. H of 0 gives 1. As I told you, h of 1 will give value on this delta. 1 minus 1 0, this will become 0, this will be 1, this will be minus 1. No value, but there will be value. It is multiplied with minus 2, so it is h of 1 will be minus 2. Meanwhile h of 2 will be 3 and h of 3 will be 0, and every other value will be 0. So for this system we got these values of an impulse response, and we can accommodate them, the x of n, using this value as follows. Y of n is equals to summation of x of n into h of n minus k, and this is, we know, it is convolution, and we can do convolution using tabular method, which I will explain now. Here I wrote some indexes, and h of k is equals to 1 2 3 4, x of k is 1 2 3 1, and we have to do convolution, so we'll flip the value of h of k. Okay, when we'll flip this, 0th value will remain under 0, and the positive values will be flipped to the negative side. Then we'll multiply this thing and add them, because it is summation of convolution, multiple of h of minus k and x of k. So only value which we'll get is 4, because here is 0, here is 0, so there will be no values in this side, so only we get with 4. In h of 1 minus k, we will shift this system to 1, so we'll do shift. So here you can see that if you multiply it now, 2 will be multiplied by 4, and 1 will be multiplied by 3, and every other values will be 0, and we will get 3 plus 8, it will be 11. Meanwhile we'll multiply, and in next 2 minus k, will shift this to 2, that is 2 values will be on the positive side. So again we'll do this procedure, we'll add them, we'll multiply them, and we will add them together, their answers, and we get 20. Everything will proceed the same way, and y of n is equals to 4 11 20 18 11 5 and 1 0. So comparatively, that's an easy method of convolution to find the output of the system. Convolution has many applications in a wide range of areas. For example, image processing, probability, CNN. Image processing, we know that we have to do edge detection, optical purpose, and adding blurring. So we use convolution in these areas. In probability, we use it in probability distribution estimation, and in CNN we use it machine artificial intelligence. So that's all from lecture number 3. I hope you understood the lecture, and see you in the next video. Khuda Hafiz.